Hey, welcome to the HTH 2021 CTF Solve video series. I'm John, and we're going to be taking a look at the Ponables Challenge 1, which was shell relay. I can't control my kids, so I'm just going to go ahead and record this with them here. Otherwise, I'll never get it done. So the very first thing that we do is we're going to download that challenge problem, which came with it. We're going to throw it into Ghidra and take a look at the main function. In that main function, what we'll be looking for is anything that'll help us interact with this challenge and figure out what we're supposed to sort of send to it and expect. All right, so let's go ahead and connect to the challenge. Again, this information was given to us in the CTF challenge. Enter command code 9. Let's go ahead and do something like help and tells us invalid command. So let's go see what these valid commands should be. In Ghidra, when we take a look at this setup, I've already documented or named a couple of variables, and this is what we want to try. So thank you. So the output is put here on the this text is put out to the screen. We're going to flush the output. The shell relay server will ask us for input. So fgets is going to get up to 7 bytes from standard in and put it into this location, which can hold 8. So everything looks good there. The next thing it's going to do is go from ASCII to an integer, and it's going to store it in this slot here, which is an integer type of command code. Next thing it's going to ask us is if our command code is negative, it's going to disconnect. If it's positive, then we're fine. So we just need to make sure that we have a positive number. It matches this case. So the next thing we need to do after this, so if we gave it, for example, that command code of 9, everything worked out. If we do this and give it a command code of 1, everything will work too. So we just want to make sure that we do a non-zero value or non-negative value. Coming up past that, it's going to ask us for a command. It's going to fgets up to 40 hex bytes, which is 64 bytes, and it's going to place that into user input. Now, there is 36 bytes here, so we can overflow this buffer, but there's a certain way that we're going to have to do this, and we'll take a little more of a look and try to understand how that happens. So once we get into the user input command, we are going to strip out the new lines from that. We're going to null terminate the end of where that actually occurred, and then we're going to check to see if crom is added to the command. So if our command is crom and it only checks the first 4 with stir end command. So our string could be very long and could have lots of things. If this were our stir compare without stir n, then there would be an issue. Our entry would have to actually be 4 bytes and would have to be crom to get down this location. If it's not, it's going to check it to see if it's stoke, st0ke, and then do something else. So essentially, the 2 different things that we can do here are enter in a value of 1 or greater, and then we can also type in a command of crom or stoke. Either of those things will work, and it'll bring us into either command crom or command stoke. So if we go into command stoke, for example, it's just going to open up the stoke log file, print it out, and then return. So there's nothing really interesting going on there. So let's go into the command crom. If we go into here, it does basically the same thing, except if the parameter that was passed into this function is 42, 41, 53, 48, which spells bash, B-A-S-H, like this. What we can do to check that is we do chr, since this is a Python terminal or interpreter, I can do 42 hex, that's our B, 41 is our A, 53 is our S, and then 48 should be our H. So that's bash. Because this is Little Endian, the way that we enter that in has to be sort of inverted. So it would be HSAB, and we'll see how to do that. So once those 2 match up, it's going to say welcome crom, and then it's going to drop us to a shell. All right. So that's what we have to try to figure out how to do. There's a couple of tricks to this, right? A couple of things that we need to sort of consider. When we enter our initial information, so for example, our input, it's going to be reading 7 bytes here into this location. Then the A to I operates on it and turns it into an int and stores it below on the stack. Then we come in and it's going to read up to 40 hex bytes, which is 64 bytes, into this 36 byte buffer. So if we put more information into that 36 byte buffer than it can hold, it will spill over into user input command code, and then finally down into command code. Now, command code is actually passed into command crom. So what we have to do is find our alignment to make sure that we can overflow the stack, overflow this local variable command code, which will then push everything down, and then we can actually make this be bash. From there, we can then execute this, okay? So this is really just about sort of stack manipulation and understanding how our input can affect the application in its running state. It doesn't matter that command code is smashed at that point because it's already been used and evaluated. Up here is where command code was evaluated. So at this point in the application, it's not used for anything else. So if it's the original value of 9 or whatever the heck we put in it, which is a really large value and will likely end up being signed or just a negative value, that's okay. We can totally do that. So how would this look? Well, make things a little simpler. I'm just going to go ahead and copy the HTH 2021 CTF repo and then get our sample payload. So this sample payload is going to kind of show us how to format this. We're going to put in a 9 and do a new line. So there's an enter after that one. We're going to add our crom to make sure that that is checked right afterwards to make sure we entered the crom function. Then we're going to have our 40 bytes of just junk. And then what we're going to do here is we're going to enter bash, but in Python, the square brackets, ::, -1 is going to flip it. I wanted to do this just to be a little more pedantic so it's understood that we're putting in bash, but you could equally just get rid of this stuff and just put in a string of HSAB so it gets flipped. And again, that's because of Little Indian. If this was a big Indian architecture, we would just leave it exactly as is. Right? The reason why we don't have to flip crom is because it's an actual string comparison. When the type that we're putting in for bash, which is actually an integer, that type actually gets flipped for the Little Indian, right? Okay, so let's go over here and take a look at what would happen if we put this information in and pipe it to this. So what'll happen is it'll say welcome crom, but we get nothing else. What we have to do, and this is very, very common for pwnable challenge problems, is after we exploit this challenge, what's going to happen is the state is going to be completely jacked, right? So we're going to just willy-nilly overflow things. The application might crash or it might just exit completely normally, and then we're left hanging with nothing to interact with. What we can do is we can do some tricks to keep standard in open so that we can actually interact with it, basically cause sort of blocking state where we can interact with it before the application continues on. And this is one way to do it. Common way is to just do cat and then less than, and then we wrap our command in parentheses. Then we'll do space hyphen, and then we can pipe it in as normal. So what happens is we get this, but then we can actually do ls and get the shell actually coming back to us. So in this case, we would just do cat flag.txt, and then there is our flag. So again, this is a hurdle that I think a lot of people have trouble with, is when you do this, like in your mind and even in debugging, if you were to debug this locally with GDB, enter in this payload, everything looks like it's working, but when you start interacting with it, literally nothing is happening. And that's because you need to keep that shell open, okay? So that's how you solve this particular problem. Hope that was interesting. We'll see you for the next video. Thanks.